So we have seen that the probability of people are smokers in country 1 and in country 2 is different, which is evidence for the second explanation. So the second explanation says that being a smoker or a non-smoker and living in country 1 or country 2 are dependent. So, and what does the third explanation tells us? The third explanation says that living in country 1 increases the risk of lung cancers for some reason other than the smoking, which in mathematics or in probability we say the probability of people in country 1 having cancer given he or she is a smoker is not equal to the probability of having cancer given a smoker times the probability of a smoker living in country 1. So from these 2 or 3 explanations, we have to do something, try to fix this Simpson's paradox, or we say to avoid the Simpson's paradox by the following sufficient condition. So which says that if one of the following holds, first, B and C are independent. So this is B and this is C. Second is the probability of A given A and C both happening given B is equal to the probability of A is happening given B is happening, and the probability of C is happening given B is happening, which is again is just what we have from these 2 explanations above. So which is A and C are conditionally independent given B. Then, if we have this one of these sufficient conditions holds, then we have the probability of A is happening given B and C is greater than the probability of A is happening given B is not happening, but C is happening. And also, and it is not possible again to have the paradox, but we have correct, or we say from an intuitive answer that the probability of A is happening given B is happening is greater than the probability of A is happening given B is not happening. So that is, if one of the above conditions holds, then we do not have to worry about the Simpson's paradox occurring. You may ask, is Simpson's paradox is good or not? Obviously, it is misleading results. Like I said in our cancer, smoker, and country example, that you collect data, you do a survey and collect data and have a table form, and you have the results. You obtain the results that the probability of smokers having cancer in country one is greater than the probability of the non-smoker having cancer in country one. And also you have another result or similar result in country two, that the probability of smoker in country two having cancer is greater than the probability of non-smoker in country two having cancer. But in total, you will have a misleading result that the probability of smokers having cancer is less than the probability of non-smoker having cancer. So we have to avoid this Simpson's paradox, and we will get a correct or a non-misleading result when we say different case in different subgroup and the result from the whole group. So in next time you do a statistic project or you do a survey, you have to make one of these following conditions be true so that you can avoid this Simpson's paradox. In particular, when you do such a survey about cancer, country, and smokers, you have to make sure that being a smoker or a non-smoker, this is our event B, and living in country 1 or country 2, this is our event C. You have to make sure that B and C are independent. Otherwise, you will or you are possible to have the Simpson's paradox. Or you can make sure that the probability of cancer happens in country 1 given a smoker should be equal to the probability of cancer given a smoker times the probability of the smoker living in country 1, which is the event A having cancer or not, and the event C living in country 1 or country 2. These two events are independent, conditionally independent, if we given event B, that is smokers. So if we know you are a smoker or non-smoker, then you have cancer and you living in country 1. These two events are conditionally independent. This is what I want to say in this tutorial, that some problem or some misleading results we are going to face during the survey or during the statistical problems. Maybe it will help you. That's it. Thanks.